In the universe that surrounds us, there are countless mysteries that could change our understanding of space. We stand on the brink of new discoveries that could completely overturn our perceptions of the past and future. For centuries, humanity has sought to peer into the very depths of the universe to uncover its secrets. And today, thanks to the incredible achievements in science and new technologies, we are ready to witness what once seemed impossible. Just recently, new observations allowed us to glimpse the earliest epochs of the universe's existence, where the first stars and galaxies were born. These discoveries have sparked a storm of emotions, prompting a re-evaluation of many theories that once seemed indisputable. Want to learn how telescopes that can see billions of light years away are helping to unveil these amazing secrets? What lies beyond our boldest hypotheses about life and evolution? Subscribe to the channel, like the video, and don't miss the most exciting discoveries that will forever change our view of the cosmos. Using the James Webb Space Telescope, scientists have discovered the two most distant and earliest galaxies in the universe, formed just 300 million years after the Big Bang. The objects, named JD's GSZ 14-0 and JD's GSZ 14-1, have broken the previous record set when other star systems were found to have formed 330 million years after the beginning of the cosmic era. The new discoveries are impressive not only for their age but also for their size. The diameter of the largest of them reaches 1,600 light-years, which is surprising for such an early stage in the development of the universe. This supports the hypothesis that star structures in the young cosmos formed much faster than current models suggest. Leading author of the study, Stefano Carniani, an associate professor at the Scuola Normale Superiore in Pisa, emphasized that the discovery of such a massive system just 300 million years after the Big Bang is astonishing. They were discovered in an area known as the Hubble Deep Field, where the Hubble Space Telescope previously detected star systems that emerged 800 million years after the universe's birth. To identify the new duo, researchers conducted observations for 5 days using the James Webb's infrared camera. Scientists suggest that the impressive brightness and size of JD's GSZ 14-0, the largest of the discovered objects, can be explained by active star formation rather than the presence of a supermassive black hole. Spectral analysis of the light showed the absence of hydrogen and oxygen, elements typical for young galaxies where intense star formation occurs. Observations at such vast distances are considered unprecedented. What other discoveries might change our understanding of the early universe? Scientists have discovered a black hole that is consuming matter 40 times faster than previously thought possible. This object is a supermassive black hole located at the center of a galaxy, observed 1.5 billion years after the Big Bang. Research on supermassive black holes in the early universe has become a key focus of astronomy, especially with the James Webb Telescope, which has shown that these objects are much larger than theories had suggested. A team of scientists from the Gemini Observatory/NSF Noir Lab project has discovered the star system LID-568, which stands out for its X-ray brightness and was studied in the infrared spectrum using the James Webb. The NIR-SPEC spectrograph was used, allowing spectra to be obtained from each pixel of the image. The results revealed that powerful outflows of material surround the black hole, resulting from the intense absorption of matter that is then ejected at extremely high speeds. The nature of the outflow suggested that it was a brief but intense event, during which the amount of absorbed matter exceeded the Eddington limit by 40 times. This finding is significant because it may explain how black holes can grow from small objects to supermassive ones in a short period of time, and it opens new avenues for theories about the formation of black hole seeds, not excluding their existence. What fascinating images has the James Webb Telescope captured, and how do they help reveal the mysteries of the early universe? What makes the Tarantula Nebula and the Crab Nebula unique? Can we use them to peer into the past of our own galaxy? The Tarantula Nebula, located in the Large Magellanic Cloud at a distance of 161,000 light-years, is the largest area of star formation in the local group of galaxies. The James Webb Space Telescope has revealed its complex structure, the composition of gas and dust clouds, and distant background galaxies. The NIRCam camera showed that the central cavity of the nebula was hollowed out by the radiation of young stars, glowing with pale blue light. Only dense clouds of dust resist destruction, forming pillars and arches where protostars are born. The NIRSpec spectrograph helped study one of these stars, previously thought to be older. It turned out to be just beginning to emerge from its dusty cocoon. The MIRI instrument revealed hidden protostars still gaining mass. Infrared waves penetrated the dust, unveiling previously unseen details. The nebula's chemical composition is of particular interest, resembling star-forming regions from the cosmic noon era, a period of maximum star formation activity billions of years ago. Additionally, astronomers presented a new image of the Crab Nebula, the remnant of the supernova SN 1054, located 6,500 light-years from Earth. Webb captured the delicate dust structures emanating from the center, where a neutron star resides. It feeds the nebula with a stellar wind, causing it to expand. This data will help understand the origin of the nebula and the mechanisms of material distribution in space. What unexpected secrets do the atmospheres of distant giants, the ancient super-Jupiter near Epsilon Indi, and the scorching WASP 39b, hide, and can JWST unveil their mysteries? The James Webb Space Telescope has directly detected an exoplanet around the star Epsilon Indi. This super-Jupiter is a massive planet with a temperature of 280 Kelvin, an age of about 3.5 billion years, and a mass of 6.3 to 8.6 times that of Jupiter. It turned out to be the oldest and coldest exoplanet ever observed directly. Epsilon Indi is a star that is 3.7 to 5.7 billion years old and is located 12 light-years away. Scientists had previously suspected that it had a large exoplanet, but this could only be confirmed with the help of the JWST. Interestingly, the planet's model predicted a certain level of radiation, but the VLT telescope did not detect it. This could mean that there are unknown substances in the super-Jupiter's atmosphere that absorb light or dense clouds that hinder observations. Other JWST studies have helped better understand the atmosphere of the exoplanet WASP 39b, which is in tidal lock. One side always faces the star, while the other remains in darkness. WASP 39b is a hot gas giant located 700 light-years away, with a mass of 0.28 Jupiter masses and a radius of 1.27 times that of Jupiter. The day side of the planet is heated to 900 degrees Celsius, and measurements have shown that the evening side is 200 degrees Celsius warmer than the morning side. The reason for this temperature difference is powerful winds that carry hot gas from the day side to the night side. There it cools down and then returns to the morning side, making it colder. These atmospheric flows reach speeds of 1,600 kilometers per hour. Now, scientists plan to study other hot Jupiters using the JWST to understand how typical such processes are for exoplanets. What other amazing discoveries could be made using the James Webb Space Telescope in the study of Saturn's and Jupiter's moons, which may hold the secrets of life in the universe? The James Webb Space Telescope has captured a giant plume of water vapor being ejected by Saturn's moon Enceladus, extending hundreds of kilometers. This phenomenon was previously observed in 2005 by the Cassini spacecraft, but it is now clear that the eruptions are much more massive. The water geysers of Enceladus contain methane, carbon dioxide, and ammonia, possible chemical indicators of life. Scientists believe the eruptions originate from an under-ice ocean with hydrothermal sources. NASA is considering missions, including the Enceladus Orbilander, which could fly through the plumes, collect samples, and even land on the surface. Webb also detected a carbon source on Europa, one of Jupiter's moons. Analysis showed that carbon dioxide appeared recently and originated from the subsurface ocean rather than from external influences. Additionally, Webb has captured the clearest image of Neptune in 30 years, revealing its rings and atmospheric features. The telescope's cameras observed high-altitude methane clouds, global wind circulation, and a bright southern vortex. 7 of Neptune's 14 moons were also captured, including Triton. Its unusual retrograde orbit suggests that it was once captured by Neptune's gravity. Further observations are planned for 2025. Each new result obtained with the James Webb Space Telescope opens up unimaginable possibilities and gives us the keys to unraveling the greatest mysteries of the universe. From the earliest galaxies to unexpected features of exoplanets and moons, all these studies reveal new horizons. If you want to stay updated on the latest and most exciting scientific discoveries that will forever change our view of the cosmos, don't miss future publications. Subscribe to the channel and stay tuned to be the first to learn about the most astonishing phenomena in the universe.